This video is just a little bit of an introduction to distributed energy resources. So distributed energy resources, we could also call DERs. DERs really have sort of a lot of definitions. You could call this district energy. You could call this a small microgrid, etc. So, but I'm going to use the term distributed energy resources because that's simply what IESO, the Independent Electrical Systems Operator here in Ontario, calls them. So I'm taking a picture here from IESO themselves, and they are defining them as resources or loads that are connected via a local distribution system. But they are smaller in scale than the traditional generation facilities. They include, but are not limited to, if you had solar panels on your house or in a commercial application. CHP, combined heat and power, combined heat and power systems, small power plants you might have at an industrial facility or manufacturing facility. You might have some small power plants. You might have some CHP as part of a community or district energy system. The storage that is built into some systems or into the grid is part of our distributed energy resources, that storage. Generators, so some facilities have generators as well. Electric vehicle could be considered sort of a aggregator, and generators, electric vehicles, etc., could come into this grid or this relationship between the transmission side and the distribution side, and have the IESO needing to rebalance how all of this power keeps all the light bulbs on, and that's really their job. And then controllable loads, so that's our loads, which means what we are using all of this for. So our appliances, our HVAC systems, etc., are basically the lights that we need to keep on. And as this lovely picture shows, is that IESO doesn't just have this traditional large-scale generation. Our hydroelectric plants, our nuclear facilities, our natural gas plants that go on and off and meet our peak, our renewable energies like wind and solar, they don't just have these major energy producers. They also have to be balancing how some of this energy can get stored for later distribution at off-peak times, for example, or when the wind is not blowing, the sun is not shining. How do we best store that so that we make less generation? How do we best use our onboard embedded electrical PV generation? Perhaps in the future, our electric cars, what do they play in a storage role in this transmission and distribution? So that's what we're talking about when we're talking about the distributed energy resources that connect into our transmission system via our LDS, our local distribution system. So this picture is from IESO website, the Independent Electrical System Operator. What does this mean in Ontario? Here's a graph from 2019, and this is the installed distributed energy resources in Ontario in 2019. And we can see here that the bulk of them were solar, and this is a result of a DER sort of study initiative pushed by IESO to grow the amount of distributed energy resources from about 2009 to 2019, around about that time period. And this was you can see around more than 4,000 megawatts of these distributed energies were installed, and this helps alleviate the dependence on those large generation facilities. And of course, it's necessary to be able to balance out the grid and use storage as well to meet all of the needs of the consumers. But you can see a vast majority of this has been solar, and quite a lot in wind as well.